Very happy to have you today, Jeff.
Thanks. Thank you for that introduction. This is my first time in this setting, so thanks for coming to this. Notice nobody sat on the front row. My students have learned not to do that, but you have no excuse, you know.
Right up.
Thank you. I was going to say, often I will spit. That's the problem, but that's fine. I have a number of things I want to talk about today, so I want to go ahead and get started. It's a pleasure to address scientists in particular. I won't try to lecture you all on science because I would do a lousy job. I'm a humanities person. Instead, what I want to do in this presentation is to provide a little insight about how historians think about the marine sciences. I'm a historian of science myself. That's my background. Yes, you can get a PhD in that. So history of science is what I did in grad school. And when I was in grad school in the 90s, I was fascinated by the Cold War and its connection to science. And I was drawn ultimately to oceanography in that. But what drew me to that subject was not just oceanography. It was things like disagreements between Americans and Soviet scientists. We'll talk a little bit about that today. On conceptual issues like plate tectonics, which the Soviets completely rejected. Controversies about practices that threaten human health, things like radioactive waste disposal in the ocean. And also, and what I focused on actually a lot when I was writing my dissertation, which became my first book, trying to face the historical meaning of an era of science that was largely defined by its relationship with the military. And I use the term military in a very general sense. Some people object to me saying military when I really mean naval. Hopefully you're not those kinds of people. Now, because scientists are often baffled by what historical research is, I'll say it's similar to what you do. We read books, we read journal articles, but our data, the real heart of it, is typically in the archives. In letters that people write, reports, and the materials that haven't made it into any history textbooks that we read in school. And so for me, that has meant over the years traveling, which is nice. It's meant traveling to oceanographic institutions, military institutions, seeing personal collections in various places around the world, universities, national archives, and international agencies in the US and abroad. And when we publish, we make claims. And we defend those claims with evidence. I say this because, what a historian produces ultimately is a kind of narrative. It's a kind of story. And it isn't just reporting on the past. It's far more contentious than that. And I'd be fascinated to learn from you, maybe at the end of this, something about the own narrative that you keep in your head about the history of your own discipline or your own work, the background that you think is there. I don't mean it in a pejorative way, like you think is there. I'm going to tell you what's really there. No. I am actually curious about the narrative that we have. So if my talk has a theme, I guess it's that I'd like to stimulate some of your thinking about the narratives that actually compete with one another about the history of the marine sciences, especially in the period after World War II, and perhaps get a little bit of your feedback about them. A little bit about me, the books that were mentioned before, I'm not just trying to promote myself here, or that's a little piece of it, I suppose, but just to give you a sense of how I got to where I am today. This first book on the left, I wanted to write about oceanographers and the Cold War, so I had this awesome title, Oceanographers and the Cold War. That's what it's about, you guys. I was really interested actually in international cooperation and this question of, how do we have so many international cooperative ventures, and yet at the same time most of it was paid for by the Navy. So I was really looking at patronage strategies by oceanographers with the military, also with the Atomic Energy Commission. Then I got really interested in this controversy about disposing of radioactive waste in the ocean, which was done for a long period of time, and we'll talk a little bit about that today. Also the role of fallout in the history of the marine sciences. My most recent book was called Arming Mother Nature. Definitely, I'll never have as good a title as that ever again. But I wanted to mention a couple of things about it. One of them is that in this particular book, which involves not just the oceans, but it does include oceanography, it was really about collaboration between scientists and the military and what that collaboration meant for how we understand our vulnerability to environmental change. And that's, arming Mother Nature. I was really happy that it got, people actually picked it up. I think in my other books it's kind of straight to video, whereas this one people actually read. Some people did. It was excerpted in Salon, and I only mention that because they changed a bunch of things when they excerpted the book. One of the things that they changed was the title of the chapter. They took a chapter and they found the most interesting things that I had written about, to their mind, which was all these kind of crazy ideas about how we're going to fight World War III using things like the oceans and whatnot. And they changed the title of it to "We Tried to Weaponize the Weather," and everything actually is kind of changed. But there are things in here. Cold War, you can't read this. It's Cold War secrets, melting polar ice caps with nukes, changing sea level, even LSD weapons were all on the table. You need a movie voice to do this. Can I tell you one thing that wasn't in the book? Aliens. They chose an image for this. For some reason, it has a flying saucer. There are no aliens in the book at all. I was asked to be on Ancient Aliens after this. There's no alien. There are no aliens at all. This became popular among conspiracy theory websites as well after this. Why I was interested in it, I already told you why I thought it was an interesting book. Really, I was thinking about the legacy of the Cold War in terms of the questions we ask and the data that we produce. So just a little kind of fun thing there. And this is the only text I'll show you, I swear. What I want to get you to think about, and you don't even have to look at this text, you can just close your eyes and just imagine this for a moment. I'd like you to imagine the narrative that you have in your mind about the history of your discipline. And I realize there are people from different disciplines within the marine sciences here. Or if you like just a story of yourself and people like you. And I'd like to leave aside the philosophical commentary that we could make about how reality is just a construction of these stories that we tell ourselves. We can have an interesting conversation over wine on that. But instead, I'd like you to think about it as a very specific problem that a historian has. It's a practical challenge for a professional historian. What is the narrative that we tell? I mean, here are some. Is the story of oceanography after World War II the story of environmental consciousness, understanding of vulnerability and change? Is it a story of discovery, of exploration? Is it about growth and institution building? Is it about international cooperation? Some would say it's about the triumph of certain kinds of values, like Bergen School values. If you've heard of that, I'll talk a little bit about that. Mathematical, dynamic, synoptic, predictive. Some would say this is a period in which the sea simply became more legible by technology. These are all different narratives that a historian, say, writing a book about this period, could use and have that be the hook of the entire story. But these are certainly not the only ones. The problem that the professional historian has is reconciling narratives that really don't compute with one another. They don't quite fit. Contradictory narratives. Especially this is challenging in science, in writing about science, because we tend to think of it as progressive, directional, and advancing. It doesn't leave a lot of room for subtlety. These are just a few possibilities. I mean, maybe some of them resonate with you. We can talk about that afterward. But how do we reconcile them? And I would say, especially knowing that it's really difficult, especially knowing that without World War II, without the Cold War, without the Navy, none of this stuff would have happened. And so we need to have a narrative that incorporates that in a way that, is defensible. I use this word defensible a lot when talking about constructing a narrative because it has to be evidence-based. These are just things for you to be thinking about. Let's talk about one way that narratives get made. You probably recognize both of these people. Good marine science people that you are. Certainly the person on the left, everybody's going to recognize. The person on the right is Roger Revelle. American oceanographer Roger Revelle urged his students to ask questions of the sea. That was his sort of mantra at a certain point in his life. Data collection was not enough. Now, there's a reason that he said this often. It's a value system that he had connected to a way of doing science that he learned from his Scandinavian colleagues. Ironically, I should say as an aside, Revelle is most remembered today for the data that he began to collect. And we're talking about atmospheric CO2. He was instrumental in initiating the measurements that show the steady accumulation of carbon dioxide in the atmosphere since 1957. Looking back, we might regard, and this is the narrative creation here, we might regard the oceanographers of Revelle's generation as the pioneers in viewing the Earth as changing owing to the activity of humans. The Scripps Institution of Oceanography, which he was the director of for a while, became the leading institution on global carbon cycle research. After leaving Scripps, he went to Harvard and continued to advocate this kind of research. And you only need to leaf through the pages of Earth in the Balance by Al Gore to know that he was a student at Harvard, that Revelle had a profound influence on Al Gore's thinking. And Al Gore would go on to be Al Gore. to win the Nobel Prize in part for drawing attention to global climate change. You can kind of see, if I frame it this way, a kind of celebratory narrative about the role of someone like Roger Revelle that makes this kind of oceanography's defining moment, the Keeling curve, the beginning of it, which Revelle was instrumental in putting into place in 1957 for reasons that we'll discuss. Is this oceanography's defining moment? I mean, can you see what kind of narrative emerges from the way that I've framed it? The resistance to absorption by CO2 is even called by some that the Revelle factor. Now, if I'm a historian trying to understand this period, I have to think, is this oceanography's defining moment? Or is this the defining moment? This is Marines dead on a beach in Tarawa during World War II. Tarawa could have been avoided. This was a disastrous landing of Marines during the war because people did not understand tidal conditions. So the Marines had to wade for much longer than anybody anticipated in the water as they were trying to assault this beach. And it was a disaster because they were just sitting ducks because for Japanese machine gun fire. Measurement, understanding of tidal conditions, that was a major lesson of World War II, and it also stimulated a great deal of interest in research. This is a military question. It's about saving lives and saving American lives, but it's a military question that is a significant part of constructing a narrative about how important oceanography was after World War II. Sea state knowledge was used in the D-Day landings. This was a lesson of the war itself. And after the war was over, lots of oceanographers who had served in uniform during the war were very concerned about, hey, how do we keep this going? How do we continue getting this level of research? Should we continue this collaboration with the Navy? Is this the defining moment? Is this the defining moment? If we construct a narrative about oceanography after World War II, oceanographers collaborated closely with the Navy, certainly the Atomic Energy Commission. This is just a picture of the second blast of Operation Crossroads. Operation Crossroads took place the summer after World War II, so a year after the bombings that destroyed Hiroshima and Nagasaki. The first blast, Able, was not very interesting. Oh, well, it was interesting, but it wasn't as interesting as the Baker blast, which sent all this water up into the air. And oceanographers actually learned a lot. Revelle was part of the team that organized this. And Revelle said, well, we're probably going to see some ecological effects, much like you would see, after a forest fire. It's kind of funny to think of it that way. He did not anticipate the ecological effects that became extremely interesting. And that was, they had to cancel the third test, which was codenamed Charlie, which was supposed to happen after this, but they couldn't get back on the ships because they were too hot. And one thing that they discovered was when they tried to go on the ships, they couldn't figure out where all the radioactivity was because they tried to hose down the ships as best they could. And what ultimately they realized was so much of it was coming from the hull of the ship because of the barnacles that had taken up the radioactivity. And all of a sudden, they started thinking about ecology in very different ways. This is a defining moment if you construct that kind of narrative. It's a very different narrative than maybe the other ones we could have had. So surprising ecological findings. Again, the third test was canceled just because they couldn't get back on the ships. I don't know if you can tell from the picture, but those are ships from World War II that were kind of surplus vessels that were towed into this lagoon so they could test. As a side note, if you're interested in, this is an aside because I can't spend too much time on it. There's also a tragic story here of large-scale use of animals as stand-ins for humans. Lots of dogs, goats, and pigs were also on these ships. All these early nuclear tests deeply involved oceanographers in the design. So what I'd like to do is pose some questions that historians have to examine in looking at any of these issues. One of them is patronage a partnership? There's a long-standing debate among historians. It's kind of an old debate about the contaminating influence of military patronage. Does it affect the culture of science? Is it okay for only the military to be funding science? This is one of the reasons why the National Science Foundation exists, because prior to 1950, the biggest funder of science in the United States was the Office of Naval Research, because they wanted science to continue. Does it affect culture of science? Does it affect the questions that are asked? Historians have written to this, I don't want to say ad nauseum because, historians think of this as ad nauseum because we've been reading about it for so long. But it's a question that continues to be there. Do scientists simply pursue the best science and then paint their projects blue, is a quote that's often used, make them seem militarily significant? And other scholars would say actually they're militarily significant from the beginning and they try to paint them white to make them seem scientifically interesting. It's an ongoing discussion about who is using whom, etc. For my money, I think about this in a slightly different way. I think that we need to not overlook the role of scientists in shaping the way the military thought. I have a picture there of, there's the logo of the Office of Naval Research on the left, but on the right, at the top you have an aircraft carrier from World War II, and then at the bottom you have a bomber. And after World War II, the Air Force, which was officially created after the war, the Air Force started going around telling everybody the Navy is obsolete, that we're never going to have a war again like World War II. There are going to be nuclear conflicts in the future, and you're never going to have a war where you need aircraft carriers ever again. This is something that really irritated the Navy. Again, this is another thing when you think about military, the word military, it really lumps them all together, which is really not so historically accurate, because the Navy was really, despite its role in fighting World War II, was really feeling like it was fighting for its survival after the war, when people started thinking the next war is going to be a nuclear war. We overlook how much the new vision of the Navy's relevance to national security was due to scientists helping them figure it out. We could spend a lot of time talking about how scientists helped the Air Force figure out how it was going to be really, really important. You're going to have, it used to be, there was this great quote from Hap Arnold, the former Air Force Chief of Staff, who said, in the past, it was pilots, pilots, and pilots. In the future, it's going to be scientists, scientists, scientists. That's the future of the Air Force. The Navy needed scientists too. And the scientists said, well, what you really ought to do to stay strategically relevant is to develop submarine-launched ballistic missiles. Then you will be strategically relevant in a nuclear age. This is not an idea that came from the military. It's not an idea that came from the Navy. It came from scientists trying to help it figure out what it can do and what it was capable of. I mention this only to get you thinking about patronage, not just in the conventional way of, well, we got to get our money from somewhere, but rather think of it as a partnership and ask those questions about what that means for the kinds of questions that get asked. Another one, does science enable the state? These are all questions that, again, historians have to confront, even if scientists don't necessarily do it. I love these pictures. The one on the left is my favorite, just because it's very clear that these people have very different conceptions of how dangerous this material is. You've got the guy on the top with a hazmat suit, basically, and then somebody with no shirt on at the bottom. These are pictures of dumping of radioactive waste into, this looks like they're just sort of posing and dumping it into a harbor or something, but you're supposed to be dumping it into the ocean. I want to say something that, in the 50s and in the 60s, there was this phrase that ecology is a subversive science. Oceanography, and I'm not trying to step on any toes here, oceanography was not. Oceanography was not a subversive science. Sometimes we like to think of scientists as being the ones speaking truth to power. You could also argue that scientists are looking for opportunities in state needs, in government needs. Oceanographers were big proponents of dumping radioactive waste into the oceans. Why? Because this was a use that they could have. This was also a source of funding. This was what I wrote that book about, using the oceanographers' enthusiasm for dumping radioactive waste in the ocean and the slow, over time, turning away of that as a practice. Americans thought of it as a wonderful oceanographic tool. You can dump radioactive waste into ocean currents, and what can you do? You can track those currents. This is part of understanding ocean circulation. You could take this problem where we have all this radioactive waste and turn it into a solution. Oceanographers were not the only ones. Al Gore Sr., by the way, Al Gore's father was advising President Truman around that time to take all this radioactive waste and just dump it across Korea during the Korean War as a way of preventing people from crossing. That wasn't done. It was just a suggestion. Just a suggestion. In ecology, radioactivity is a great tracer. Ocean circulation also. When it became controversial to do this, oceanographers focused on the uncertainty of it. What you're looking at on the right-hand side is from the New York Times as well, and this is one of the reasons why the United States ended its practice of dumping radioactive waste in the ocean. Because once the American scientists, sorry, let me backtrack, the National Academy of Sciences put together a top group of oceanographers to advise the government on where to do all this dumping. Well, and then they published this in the New York Times. Well, if you live in Iowa, you're like, oh, that's great. I'm glad the scientists are on top of this. But if you live in South Carolina, or you live in any of these coastal states, this is a problem. Or you live in Mexico, this is a problem. This was such a there was such a firestorm of controversy after this that this became a huge problem for oceanographers. But it wasn't until it became a controversy that oceanographers themselves began to turn away from the practice. I'm talking about American oceanographers in particular. Because before that time, they were saying it was a good idea. So this moves into the next question, which is, who gets to speak for the oceans? Which scientists? Now, you are all in a marine science center, but you're not all doing the same kind of science. And sometimes you probably think, why does that colleague of mine always get asked the questions by the media? What about my field? That is not a new feeling. Who gets to speak for the oceans? Who are the authoritative scientists? Who are the ones that people actually turn to ask questions? Which experts? In the 60s, you can imagine how irritating a person Jacques Cousteau was to most marine scientists, because he got all the attention and he was always drawing attention. Why are you doing this? Why are you doing that? Oh, you're dumping radioactive waste into the Mediterranean. What? That's not... And there were people who had spent their careers justifying that practice, who were themselves also scientists working in the government. Who gets to decide who says something is safe and isn't? If you're tempted to view, again, the history of this period as scientists simply speaking truth to power, I'd like you to think about it differently. It's also about authority and a battle for authority. What scientists get to actually speak for the seas? Why don't I have a picture of this appetizing thing up here? So, consider how hard the British fought. I mentioned that the Americans, decided it's too hard, publicity-wise and diplomatically, to dump in the oceans. Well, the Americans have Nevada, and the Russians had Siberia. And the British were like, hey, I thought we were doing this. And so the British, they tried to dump in Wales, and the Welsh said, no, thank you. And so they said, listen, we have decided that the best place for our radioactive waste, despite what the Russians say, because the Soviets were just like, oh, you're poisoning the well. That's where the term poison the well comes from. You're poisoning the world's well. You're dumping radioactive waste in the oceans. We don't do that. That wasn't true. But we don't do that, and you shouldn't do this. And the British said, listen, we've decided we do it. We've got all of our scientists who say that this is the best thing that you can do, and they protected this practice. The reason I have this very appetizing looking meal up here is that I'd like you to think about, the consequences of that authority. In the UK, I don't know how much you know about, like Hanford and the plutonium production that went on at our plutonium production facility at Hanford, but the British had one at Windscale, which you can kind of see on this map. It's the one thing that's marked. And they piped a lot of their radioactive waste into the Irish Sea. Most of the big-time, press-worthy moments of this particular story happened because of big canisters of waste that were washed ashore on beaches, and people would say, oh, I can't believe this happened. And that happened a lot. I mean, the British dumped a lot of radioactive waste. They dumped it in the English Channel. They dumped it in the Bay of Biscay. After the Americans abandoned the practice, they went to Europeans and said, we need you on board, because if you're on board and we're dumping your waste, you're not going to criticize us for it. But the amount of waste that was dumped from ships in those canisters just paled in comparison to what they actually just piped into the ocean through the pipeline from Windscale. And the consequence that I want you to think about is of authority to make decisions for the oceans, or to speak for the oceans, is the concept of contamination that the UK had in the 1960s and into the 1970s as well. And the concept of contamination was, we can pipe as much radioactive waste through this pipeline into the Irish Sea. By the way, guess who objected to that? Ireland. We can do as much as is, and here's the defensible part, as is defensible, because the way that we understand contamination is you humans. How does this contamination get to you? What is the most critical pathway by which radioactive contamination is going to get to you? They called this critical pathways. The critical pathways approach was all we have to do. We don't have as much money as the Americans have. We can't just study everything in the ocean. We can't just look at every single organism. But what we can do is figure out what the most likely pathway is to get to your breakfast table. And that is, it turns out, they determined this to be edible seaweed, which concentrates radioiodine, and was the Welsh are going to get this one way or the other, which was a delicacy, or I should say delicacy. Can it be a delicacy in Wales and also parts of England? I've been told I shouldn't go point, so I'm not going to point. But on the right-hand side, that nasty green thing, this is edible seaweed mixed with like an oatmeal. I'm sure I've never tried it. It's called lava bread. It's spelled Laver bread. And this is the critical pathway. And what they did was to decide, okay, what's the average amount of lava bread people eat in Wales and in Cumberland, the area that borders on the Irish Sea. And as long as we keep the amount that people are getting exposed to below the lava bread exposure, we can put as much as we want into the ocean. Now, there are lots of things to think about on that particular issue. One of them is simply, you're only thinking about humans. You're not thinking about what the effects actually are in there. But what I'm just trying to get you to think about is who gets to speak for the oceans. In this case, it was a bunch of radiobiologists who were trying to defend dumping radioactive waste into the ocean when the Soviets especially were just constantly criticizing them for it. After I wrote a book about this, there was a ship. I mentioned there were a bunch of operations in the Bay of Biscay. There was a sailor who had been on one of these dumping operations who contacted me after somehow he'd found, these are straight to video books, folks. Nobody reads academic books. But somehow this guy found this book and said, I was on that ship. And I refused to go on the radioactive waste dumping operations. And this is not a scientist. This is some guy who works at the docks. You have to think about the practice of this as well. These are people who are vulnerable, who are really willing to get overtime pay. And he said, I just wanted to do the cyanide operations. I didn't want to do the radioactive waste operations. This is literally what he wrote to me. But he said, I know from a story of what happened. There was one time, and I found actually a lot of documents about the stuff just not sinking into the ocean. And so what they would do is they would shoot at it and try to get it to sink. If a Spanish fishing boat was coming nearby, it was sort of like hurry up and get this stuff out because all of a sudden there's beakers floating. But what this guy told me was that shooting it, trying to collect it, one of these drums just was not sinking. And so what they did is they sent one of the sailors into the galley to get a cleaver, to jump into the water and just start hacking away at the radioactive waste drum until it sank. Now, I can't verify that this happened. This is a story that somebody told me, having read the book and said, I was on that ship. Or rather, I didn't go on that ship. One of my friends told me the story. So it's sort of, second, third, fourth. The other question I'd like you to think about is who sees the sea? This is something that I was just actually talking about a few minutes ago with somebody. The Soviet Union completely rejected the theory of plate tectonics. And this is actually what drew me to the subject to begin with, because I was so fascinated by this. I just thought, why is it that across international lines, during a time in which people were saying a lot, that science is breaking down these geopolitical tensions and easing them and breaking down these borders, how is it that the Soviets and the Americans and Canadians, on the one hand, Soviets on one hand and the Americans and Canadians on the other, are completely at odds over something that is just a scientific issue? But they were. The American data came from the oceans. And it wasn't just that the Soviets were unwilling to look at the oceans. They just didn't have access to the same data that the Americans had. Much of the early research was classified military data, and the community of scientists who were involved in bringing out the theory of seafloor spreading, fracture zones. You're seeing some of the stuff. This is these were not maps that were produced at that time. These are later projections. But the kinds of discoveries that scientists are thinking that they're making in the oceans are coming from ocean instrumentation and ocean sciences. And the Soviets are not participating in that in the same way. Most of their way of understanding tectonics was in vertical tectonics or continental tectonics. This is a period in which there are other issues related to this too. One of the discoverers of seafloor spreading, Harry Hess, described it as geopoetry because it was very simplistic and schematic at that time. It was just an idea. And this is precisely the kind of science that the Soviets said was classic Western, oversimplified, and not based on a lot of empirical data. So they rejected it. I found it fascinating as well that one of the attempts to bring all this stuff together was at the 1968, there was this geophysical conference or geological conference in Congress in Prague. And during the meeting, when they were trying to discuss plate tectonics, that was when the Soviets invaded Czechoslovakia. And the Soviets just disappeared from the meeting. And suddenly it was we're going to leave them behind. So in the West, plate tectonics was known as a Western theory, and one in which the Soviets were not participating in it. Decades later, Soviet scientists, embraced plate tectonics. Decades later, Russian scientists embraced plate tectonics. But at that time, it was, a major conceptual difference. But I would say those who embraced seafloor spreading were part of a community, and it wasn't one that included the Soviet Union. It was as much a cultural and social change as it was a scientific one. And it was one that cast the free world science cast it as the free world science on one side and an outdated paradigm on the other. Okay, so those are some questions. And what I want to talk about now is some specific things that happen. I suppose some questions facing the historian. And now I want to pose a basic narrative disconnect. So remember, I started with Roger Revelle being this hero of the environmental movement because he was the one that started this, I had him with Al Gore. He was one that started this tracking of accumulation of carbon dioxide in the atmosphere. If you're a historian looking at documents from the 1950s, and you're looking for this hero of the environmental movement, you're going to look in vain. You are not going to find him. You're not going to find them. Oceanographers of this era, the 1950s, were far more likely to be helping blow up atolls in the Pacific than trying to save the Earth. And that's just the historical reality that we have to contend with. And when we construct the narrative, how do we put that in there? There are certainly links between the post-war Earth sciences and the rise of concern about anthropogenic climate change, but in many ways it is reading back into the past based on what we would like to think was going on at the time. Like his contemporaries, Revelle in that era was motivated by entirely different kinds of questions. Matthew Fontaine Maury, the most well-known oceanographer of the 19th century, was really going out of vogue during this period because he called his science physical geography of the seas. It was very descriptive. And this particular view among oceanographers in particular had come into disrepute and ridicule. It was too descriptive. You needed to have more dynamic mathematical modes of doing science. Other scientists, when they look at, how do you see the oceans? If you're a geophysicist and you're interested in Morris Ewing, who was the director of the Lamont Doherty Observatory for years, he just said the ocean was this murky mist that was kind of in his way. He wanted to see the bottom of the ocean. And there are ways to kind of think about what the ocean means to you. The Scandinavians, I'm specifically thinking about the Bergen school, so Bergen in Norway, that's usually associated with Wilhelm Bjerknes, and Harold Sverdrup, who came to the United States and was the director of the Scripps Institution of Oceanography. He is one of the ones, actually, who brought some of these ideas to the United States. Very interested in mathematics, in understanding circulation, large-scale motions of water, air-sea interaction. It involved things like constant data collection. It was supposed to be predictive. You're supposed to go out to sea and collect data. These are all values that he instilled in his kind of protege, Roger Revelle. Side note, Harold Sverdrup, I don't know if you know the story. I know Carmel knows the story about Harold Sverdrup. He had to leave. Imagine being the director of an oceanographic institution that has these links with the military, and you're not allowed to look at the data because you can't get classified clearance because people suspect you of having Nazi sympathies. That was the problem for Harold Sverdrup, because I guess his wife was very vocal at social engagements about, I don't want to get it wrong, but them not being so bad or something. After the war, he left, and he went back to Norway, and then he became a major collaborator with the United States, and I'll talk about that in a moment. When we think about Bergen values, we're thinking about large-scale, dynamic, mathematical stuff. This is how you're supposed to see the oceans. This is what Ravel is believing. Not just Ravel, but other names that you probably are familiar with, people like Henry Stommel, who said we need to get beyond cookbooks and tradition. That's what the old oceanographers were all about, and we need to mathematize this stuff. So like I said, Sverdrup left under scrutiny. Ravel ultimately became the director of Scripps. And the kinds of work that you do when these are your values are very conducive to collaboration with the military. Because honestly, they're the same kinds of questions. You end up having a classified science. Think about what the Navy wants during this period. If you were to look, I'm tempted to go and point, but I'm not supposed to point. But if you just look at the left picture there, what you're looking at, and this is just a capture from Google Maps. This is not a historic picture. This is identified in almost every naval strategic planning document that you can look at from the early 1950s as the most problematic area if World War III breaks out. Because it's an area that we, being the United States, know very little about. We don't know what the limits of ice are. We don't know what the sea state is in any given month. We simply don't have the data that we need. We don't know what disrupts the behavior of sonar in this crucial bottleneck. And why is this so important? Because this is where the ships are going to be coming out from the Soviet Union. This is how the Soviets are going to access the rest of the world with their fleet that's on the European side of the Soviet Union. So we need to understand this area. And it just so happens the kind of stuff that these dynamic oceanographers are doing, collecting data on salinity and temperature and current direction, looking for things like thermoclines in the ocean, these are exactly things that the Navy wants. Go and collect this information. Problem is that a lot of that data is perceived as operational data, and so it remains classified. So if you're a scientist trying to make your name, it's really hard to publish and be known, to get a job in a university, whatever, if all of your publications are behind a wall of secrecy. Enter an event that is known as the International Geophysical Year, which I'm sure you know something about, or at least have heard of. And maybe you don't. I can give you just a brief overview of it, but I'd like you to think about it as something that is extremely useful for strategic reasons, rather than just thinking about it as this great collaboration between over 60 nations took part, and this was really wonderful for science. It was, but we need to think about why government supported it as much as it did. I have this picture on the right-hand side which shows the Navy trying to land at the South Pole in 1956 in preparation for the International Geophysical Year of 1957, 1958. Why did they do that? Well, we can talk about that. It's sort of a race to the South Pole. The Soviets were also racing to the South Pole. The Soviets didn't get there. The Americans were just so happy to get to the South Pole first, land a plane in Antarctica at the South Pole, and the Soviets said, fine, we're going to land a plane at the geomagnetic pole. You did some geographic thing, we're going to do more scientifically defensible thing. And they did. This is the level at which the US and the Soviets are really antagonizing one another. Why was it so well supported? Collecting loads of data in sensitive areas, the North Pacific or North Atlantic in particular, Antarctica in particular. The military needed this data. The Navy needed this data. Collecting it as a collaborative venture was a way to do it under a peaceful international cooperative venture. Nobody expected the Soviets to participate in this, but they did. And that in itself was kind of a problem. The Soviets sent a massive oceanographic expedition to Antarctica, which had Americans scratching their heads wondering, what did we just do? We just invited all these Russians into the waters around Antarctica and the North Atlantic. The Soviets did this for the same reasons that the Americans did. It was also under this that the Soviets launched Sputnik. So it was very handy for the Soviets, just like it was for the Americans. It was during this period that the United States started collecting this data. Revell was fascinated with carbon-14, which could be used to judge the age of water. He wanted to know how long the CO2 remained in the atmosphere before dissolving into the ocean. He and a nuclear chemist, Hans Suess, published on this. It became this famous essay about whether or not what we produce from carbon dioxide will in fact be absorbed by the ocean. And he raised this question, well, I don't know. Let's start measuring this. That started during the International Geophysical Year. Was it concern about carbon, or was he concerned with demonstrating that there's plenty of mixing into the oceans? Because at this time, there was also this question about nuclear fallout, and a big question about whether or not the United States was contaminating the world with all their nuclear tests. And people like Revell were saying, we don't think so. We think there's plenty of mixing. So let's find out, what is the upturn of the ocean? That's why this kind of study is being done. It's not, gee, I'm concerned about carbon dioxide. It's let's start tracking this stuff. Why do you need to start tracking this stuff? Let me say a couple of things here that happened. When is science significant is the question that's up there. After the U.S. started doing all this nuclear testing, other countries started saying, hey, are you contaminating the oceans? And are you doing something that is permanently having an effect on the oceans? And American oceanographers, you know what their answer was? We don't know. We don't know because nobody knows what the normal ocean, put that in quotes, nobody knows what the normal ocean looks like because we only started measuring after we started testing. So we have no baseline. That's one of the reasons why the IGY was perceived as being so important. We need to develop some baseline for understanding any kind of change that happens afterward. I mentioned this particular test. I don't know how much you know about nuclear testing, but this was one of the first hydrogen bomb tests. And hydrogen bombs are about 1,000 times the size, can be about 1,000 times the size of fission bombs. So this Bravo shot, it's a famous shot in 1954, was measured in 15 megatons, which is about 1,000 Hiroshimas. And that's why it was out in the Pacific. I don't have time to talk about the Marshall Islands story, but that's where this was done. But the controversy was a lot of the fallout from this test ended up blanketing this fishing boat, a Japanese fishing boat, and causing a massive international controversy about exposure to fallout and what the United States is doing. And asking these questions about what questions do we need to ask of the sea? Do we need to be thinking about just circulation? Do we need to understand all these things that the Bergen School people are doing? Or should we be doing what the Japanese are saying? We need to look at change over time. Are we in fact changing the ocean, which is what Japanese scientists were doing at that time? Revell, before this was happening, just to stay on Revell for a moment, so we have a character that goes through this whole thing. Revell was, before this shot happened, he was in Japan, he was touting nuclear power to the Japanese, promising that there's going to be the great benefits of nuclear power in the future. After this happened, this Japanese fishing boat went back to Japan. There were some oceanographers there, American oceanographers that the Japanese avoided like the plague. Evidently they were insensitive, saying that this was not a big deal. Are these issues with nuclear exposure, are they political questions? Are they scientific questions? Is this Revell thinking, oh, well, I need to promote nuclear power. These Japanese scientists are saying, well, maybe we should track change over time. It's in this moment that you do, in fact, see American oceanographers saying, well, maybe we should start tracking change over time. After this happened, the first vessel that went out to track to see, okay, what did this Bravo shot do? What does the ocean look like after all this debris has gone out? The first ship that went and did that was not an American ship. It was a Japanese one. And it wasn't a Japanese fishing vessel. It was a Japanese scientific vessel that was trying to establish some relationship between the US nuclear tests and the state of the ocean. And the chatter between American oceanographers at that time was, we can't have this. We can't have the Japanese sort of getting ahead of us on this issue. We need to make sure that we are framing this issue. But also, why are they out there and we're not? Why are we allowing some other country to determine what is significant about this ocean at this moment? You get and I'll sort of draw to a close here. What questions do we ask of the sea? These are Japanese, this is a posed picture. I don't know how many of them are actual scientists, but these are the Japanese looking at the tuna coming off of this ship and trying to study it and trying to understand it. In Japan at that time, and outside Japan too, people who are concerned about nuclear testing, the kind of question that seems significant is changing. And the US oceanographers are going to change eventually too, and to try to think in terms of this being a significant question, change over time, and possible permanent changes to the oceans and to the atmosphere, but it comes from outside. It's not something that the Americans are doing internally. Americans are still asking about circulation models. The Japanese are asking about long-term change and contamination. So this is the ship, by the way, the Shinkotsu Maru, not the Lucky Dragon that was the name of the ship that was blanketed with debris, but this is the scientific vessel, the Japanese scientific vessel that went out there and started taking data and started publishing about contamination, saying we don't know what the normal ocean is. Let's acknowledge that. We don't know what the normal atmosphere is. Let's acknowledge that. Ravel became famous for a view that suggested that the atmosphere and the oceans were changing, but in fact he came around to that view only after others with social demands of their own, very important social demands from their point of view, began asking. So I'm not here, and I'll just close with this, I'm not here to provide a sort of a quaint history of a few scientific episodes that ended up being politicized. Instead, I'm kind of presenting you with a historian's problem. How do we talk about this scientific history without talking about all this? How do we talk about this as just one idea after another without understanding the different questions that were asked for lots of different kinds of reasons? What we know about the past depends on the questions that we ask of it, just like Ravel said of the ocean. It's not something simply to be measured or any more than data from the ocean can just teach us on its own. But you're the scientist, not me. I'd like to conclude, I guess, with an invitation for discussion so that I can learn how you see this past, if at all, shaping the way that you perceive your own fields. And I'll end it there. Thank you. Yeah. I could maybe, since I don't know most of you, I know a few faces, could you say who you are, and that'd be helpful to me.
So radioactivity went through this evolution of denial and then acceptance and then a response. But now we're doing that with climate change. Is the culture the same? What's a historian's view of that? Why is there such a big pressure against the truth of climate change?
I mean, I can't give you a very good answer to that, but you don't already know. I mean, it's highly politicized. I mean, if you have, I mean, climate change is obviously very important, but it is one incarnation of this, where you have scientists over here, scientists over there. You have a group of people who want to do one thing. It's not really a scientific issue. It's a politicized issue.
So is nuclear.
Yeah, exactly. That's what I mean. It's not. This is just another iteration of this issue. Go ahead.
Well, I guess with radioactivity and the nuclear weapons, first we had half of them in the war, and then they were going to do all these magic things for us. They weren't so bad. Don't worry about it. And then that's changed, obviously. But for climate change, the physics and chemistry is very pure and simple. We didn't win a war with it. It's only has the negative side, but it's creating just as much political backflow as the nuclear stuff, which to me is kind of amazing because it's really straightforward. It's really easy to measure. It's really clear. There isn't any controversy.
I wish I had a great answer to that, but we are all living, I mean, I'm a historian, you're a scientist, but we're also living in this moment and dealing with a political situation in which that's the case, that there's a lot of pushback against it for reasons that are not scientific reasons. It's anti-scientific reasons. So yeah, I feel like I can't really add more than what everybody in this room probably already perceives about that.
Isn't funding entering in? Surely different groups want money for one thing and different for another, and so surely climate change could be sort of analyzed that way to see, who's winning for money. I'm sure that influences the politics as well.
Oh, definitely. I mean, so even if you take climate change out of it for a moment and just think about like radioactivity, I mentioned that once it became an issue, by the late 50s and early 1960s, especially when people are really concerned about radioactive waste in the ocean, I don't want to be totally cynical. I always tell my students, put your cynical hat on for a moment. The oceanographers were very good at getting money for studying the effects of radioactive waste in the ocean. And they became such a thorn in the side of the Atomic Energy Commission. And this is especially true in France. The French Atomic Energy Commission, and I looked at their documents when I was writing about radioactive waste, they hated Cousteau. Not because they thought he was like this righteous person who was, it was because they perceived him as being a total opportunist. They perceived him as in it for, if he is easily mollified by research funds, he's not a legitimately concerned person. And that's a lot of the concern among the Atomic Energy Commissions, and they would in fact get together and talk about public relations, the different Atomic Energy Commissions, how they were going to relate to oceanographers. They would say, listen, you have to pay them. And not pay them off, but that is the perception, that if you give them research funds, that will satisfy them because they can talk about the uncertainty of your practice. And the converse of that is you can't get away from paying for research funds because the moment you refuse those, Scripps or Woods Hole or whoever, some research funds, and it's like, oh, it's not necessary to understand the effects of radioactivity over in this part of the ocean, you're vulnerable. And the press can say they don't think it's important to know that. So I'm not trying to defend the Atomic Energy Commission at all, but that's the dynamic. It's a very antagonistic thing. Whereas in the 50s, it was much more cooperative, an institutional collaboration between the Navy and the oceanographers, the Atomic Energy Commission and oceanographers. But by the 60s and 70s, oceanographers are sort of following the breeze a little bit in terms of research opportunities, which puts them in an antagonistic relationship. Yeah.
If I can, I hope you can hear me. But, so I guess it shouldn't be too surprising that the Japanese were motivated to study long-term effects of radioactivity exposure.
Right.
Power Nagasaki and Hiroshima. So was that a trend that was present in a lot of different tests at that time? I mean, were the Japanese ones leading the research and long-term effects?
They were after this. Well, that's actually a very complicated story. So let's remember also that Japan was occupied until around 1953. So the 1954 Bravo shot that blanketed the Japanese ship, that was very soon after the Americans were out. And there was an independent press for the first time. And Japanese scientists did, in fact, lead the charge saying, we have to get behind this. We have to send a ship out. We need to understand this. And if you want to look for not anti-American sentiment, but rather sentiment that is, against nuclear testing, you're going to look to the Japanese scientific community. But that's going to change. And I say it's a complicated story. This is actually something I'm writing about right now, which is I'm writing a book about the spread of nuclear technology for lots of different reasons, especially in countries of the developing world. Japan at that time was considered developing world. And their newspapers collaborated with the US government to really put a positive spin on nuclear issues in the mid-1950s, which really turned public opinion around. And that changed scientific opinion in Japan. So it's a complicated story. But yes, it's not uncommon to oppose nuclear tests during this period. It was a major issue in the 1956 presidential campaign in the United States. President Eisenhower wanted to continue nuclear testing and said fallout was not a big deal. Atomic Energy Commission chairman said, there's no way you're going to be harmed by any of this stuff. There are no, the scientists tell us this is not a problem. And Adlai Stevenson, who was trying to become the president, had his scientists who were saying, actually, you're adding to the mutation load of everybody on Earth with every one of these tests. And you had some scientists, the science actually wasn't too controversial. You had some people saying, well, you get more radiation by moving to Denver than you get from a nuclear test, or getting in an airplane or whatever, because you're cosmic rays. Whereas, the other side would say, but that's cumulative. You're willfully choosing to have birth defects in the name of deterring the Soviet Union. Go ahead, Carmel.
So I have a question, which is the Japanese did a lot more oceanographic exploration and research during the 20s and 30s than the Americans did. So were they perhaps building on the work that they had been doing post-war and the studies that they did have of the ocean where they had done research?
Well, Carmel, this is great. I mean, you are the expert on the fish side of this for sure, and I want to you probably would know the answer to this better than me. But right after, around this time is when you finally have fishing opportunities. After the war, so they're building on a lot of the scientific research that is done about bomb tests by the Japanese during this immediate post-Lucky Dragon incident is related to the fishing industry, is related to, okay, is this going to harm not just us in Japan, although that also is addressed, not just our agriculture, although that also is addressed too, but is this going to affect tuna? And that is, that's a lot of the science has to do with this kind of circulation thing. Where are all these contaminated fish going to end up going? Are they just going to be in this area, like the Americans said? They said, stay out of this area, or do they in fact migrate? So a lot of, life cycle research in tuna is going to come out of this, but a lot of it's motivated by trying to show that nuclear testing should be stopped. So the question always is for a historian of science, what stresses do you know? I know Carmel has one. She knows this. Is they're trying to figure out how much these social and political questions inform scientific questions. And if they do inform the scientific questions, what does that mean about the science itself? I shouldn't use the word contaminated because we're talking about contamination. But how does it influence the work of science? The question itself is coming from these social needs.
So what you're hearing is essentially something that is many people have heard that many times. The answer that you get, and then the questions is asked. So you're really looking very at why we ask certain questions.
Yeah.
And that is, I think, great.
Well, I appreciate that. I'm glad that you approved that. I mean, I think that. I didn't mean to dismiss it.
It's an important thing to examine. And, as you said, all of us should be examining that question.
Yeah, I appreciate that. And I guess what I would say to that is the way I approach this talk is I think, okay, you all are the practitioners. I'm not going to say, oh, this is what happened. This was right and this was wrong. But rather, think, okay, in my profession, what do I have to do? And most people are not thinking about history as something that even is contentious. It's just something you go look up. It's in Wikipedia, right? There it is. I mean, but that's not the case. You have to construct a narrative, and you have to be okay with the narrative you construct, depending on what your own agenda is. And if you are thinking about, okay, I need to have what scientists think this is all about, but also look at these documents, and also see what the social context is, I have to come up with something that I'm okay with, that I think actually tries to answer these very important questions that maybe a scientist isn't asking in his or her daily life. Go ahead.
How much is science dictated by what causes diseases in the world? I mean, is that correct? What is about radiation is important. I just wonder, because NSF doesn't listen to what their funding is given them. We're seeing a lot of that now.
Yeah. It's a great question. So I mentioned, I had a slide over there that showed the logo of the Office of Medical Research. One of the things that was a problem with the creation of the National Science Foundation the National Science Foundation was all federal money that was supposed to go through this foundation. That That's just not happening. The military wanted to continue funding science. So for a long period of time, we still had the vast majority of scientific funded research in the country was funded by some armed services or Department of Defense only entity. And then you had the National Science Foundation over here. And it was far easier, this is especially a view that I saw among oceanographers, it was far easier just to work with the Navy than it was to work with the NSF. It's easier to get grants. Because all you had to do was convince a few people that this is something that could possibly be useful. You had these true believers in basic research in the 40s and 50s, whereas in the NSF, you use the weeks. You have so many hoops to go through, and you have accountability with NSF that is public. So you have Congress saying, why do I have to care about the sex life of a fruit fly? When an ethicist is saying that that's genetic, and you don't have to do that behind closed doors, right? And when you're dealing with it, I mean, it's something that's easy to kind of recognize and laugh about, but when you're trying to think about how that affects funding practices, it's very important. I think that happened. So it really wasn't until the late 50s, after the Soviets launched Sputnik, that the National Science Foundation had any kind of real budget. It was the International Geophysical Year where things were really ramped up. It was supposed to be this one-shot deal where it was going to ramp back down after the International Geophysical Year. But it never ramped back down. Because as soon as the Soviets had the satellite into space, it was like, oh my goodness, we're behind in science. So funding just skyrocketed after that for the National Science Foundation, but also for the military. Yeah. There's some British stuff in there. I've been
But yeah, about the winners, right? And I'm wondering if you had other, if you were doing the research, you found like researchers' perspective on this, or how that influences scientific research versus kind of that day you have to produce this scientific research that all the scientists are basically forced to make data to please their funding research, shall I say, versus more specific, like you actually want to know what's going on. So I'm wondering if you encountered other
Yeah, it's a good question. I mean, I like to think about, I've been to several archives outside the United States. When I first started this, I was really interested in international stuff. And so I was interested in going to all these different international organizations. What typically comes up is this issue of funding. And I don't have a great answer to you, so I'm going to make my way through this in a way that is basically about money. And that what you'll see from the British, so George Deacon, who was the head of the British, National Institute of Oceanography for a long time, used to complain about how he had to sell equipment just to pay for someone's stipend. I mean, he was, I don't want to say he was a whiner, but he was kind of a, we're not like the Americans who get funded we're not rich. And you see that in all these different, especially European countries, who feel like they are part of this explosive growth in oceanography, but on a shoestring. Now, that may not be what you're asking. But usually, when I think about a non-U.S. perspective, it's these interesting cases of like the critical pathways approach that I talked about before, where you kind of see, okay, what does this mean? This perception of themselves as not having quite the resources that they had, but also defending the decisions that they're making very, very vigorously. Like we're only going to focus on this edible seaweed as the main way, the main thing we need to understand here. You actually get people who are not necessarily, oh, for me, I can't be a good scientist, but rather, this is sufficient. This is good science. We're not going to mess around with that other stuff because we don't have the funds for it. We don't have the luxury of studying every little thing like the Americans. No, as Americans, you also know it's not totally easy to get money. That's a perception, a false perception too, but that's a perception outside the United States. Good non-answer.
I can't say like, oh, what the Germans think, what those Soviets think, in terms of how they allow their scientists to do research, because they may not be allowed to do research that makes the country look bad.
Yeah, well, let me give you one anecdote, and I know people are sort of wanting to leave. One anecdote about the Russians. So I had an opportunity to interview someone. I just told this anecdote actually. I had an opportunity to interview a Russian oceanographer when I lived in. I had a postdoc in France, which is Paris is where the Intergovernmental Oceanographic Commission is set up under UNESCO. And I went through all their documents, a lot of documents there. And I interviewed them for a while. I was there. And this Russian was talking about the rejection of plate tectonics by the Soviets. What he said was it was extremely frustrating to be a Russian oceanographer, a Russian geophysicist, who wanted to publish on plate tectonics. But because a few people controlled all the publishing venues and controlled access to ships, even if you wanted to say, I embrace seafloor spreading as an idea, you couldn't get access to ships, you couldn't get access to publishing, you had to toe the line. And so you have these institutional or maybe country-specific cultures where very, very powerful people, for ideological reasons or for whatever reasons, are able to control the situation. You have that to some extent in the United States as well, but definitely in the Soviet Union, you simply couldn't publish in favor of plate tectonics during that period. That doesn't mean that at the individual level, or go to a conference, you couldn't meet somebody and have them say, yeah, we know. And that did